Welcome friends, welcome to the lecture series of analog electronics. In today's lecture we are going to discuss about the operational amplifier, that how operational amplifier work, what do we exactly mean by the operational amplifier. So the operational amplifier is nothing but a multi-stage amplifier which uses a number of amplifier stages interconnected to each other. Uh, the integrated operational amplifiers offers all the advantage of monolithic integrated circuit, such as small size, high reliability, reduced cost and less power consumption. So after these two sentences, all of you must be able to understand that operational amplifier is nothing but amplification process is being done inside it, and it is a 8-leg IC that we are going to study after this. More oftenly, this idea came from the concept of the differential amplifier. So the differential amplifier is nothing but we have two inputs, and it will be like that. It will be amplifying the difference between the two inputs. Then it will be called as differential amplifier. So another aspects we are going to learn in this video. So let's understand how operational amplifier is working, and what is the circuit diagram of it, and what type of circuit symbol is being used into the electrical circuits. So operational amplifier seems like this kind of thing. Here you can see that a triangle is shown, but there are two signs. One is minus sign and here is a plus sign. Now what it is indicating, that negative sign indicates that the input will be inverted after providing it to the input, and it will be shown, the reflection will be shown at output terminals. Means if I will apply for the positive and negative cycle, first will be the positive and second will be the negative half cycle. Then output will be the first negative half cycle, and then after positive half cycle. So it's kind of thing that inverting is being take place over here, and after that non-inverting input is applied to here. That means if you apply the input over here on this terminal, then it will be showing the same output as that of input. But what is the difference of using this and not using this? That is amplification. We can see the amplification in both the cases at the output terminals. The amplitude is being large at the output terminals, and here you can see that is positive supply voltage and negative supply voltage. The supply, which basically a circuit required, that we are providing over here. So that is the thing. So here you can learn these things, that the input terminal marked with negative sign is called as an inverting terminal, and if we connect the input signal to this terminal, then amplified output signal is 180-degree out of phase with the input. So that is the basic logic behind this, and that's how the operational amplifier will work. So here you can see that circuit diagram is shown over here, and this is the cheap specifications, that what on what terminal what you should apply. So here you can see there is a 8-leg IC diagram is provided over here. First is offset null input, that is negative input and positive input. They are our inverting and non-inverting terminals. Negative supply voltage, that is a no connection pin is provided. There is no significance of this particular 8-number pin, but what is there, it is to provide mechanical balance to this IC. And this one is the positive supply voltage, and this one is output, and this one is the offset null. That means we can say that that is no connection pin, but there is a positive offset over there. So that's all for this IC pin description. After that, we must be learning for the different parameters of these circuits. So let's go into the parameters. So here you can see that positive terminal is shown over here, non-inverting terminal, and what happens to the non-inverting terminal whenever we apply the input at the terminal. And this is one is the offset null. This kind of IC can be seen whenever you refer to the 741 IC. So this is the basic idea, and this one is the block diagram. Let's understand what do we exactly mean by this, that the operational amplifier is basically working into the four stages. The first one is the input stage, wherever the dual input balanced output differential amplifier can be used in this section. That is our input stage of the operational amplifier. After that, it will be coming to the intermediate stage. Now what do we exactly mean by that? Dual input unbalanced output differential amplifier can be used in the intermediate stage. So that is all over here. After that, you can see that level shifting stage. Then what do we exactly mean by level shifting? That we can use this operational amplifier as an emitter follower using constant current source. So these all are the different properties wherever the different types of operational amplifier are used with a different operating conditions. And after that, output stage is there, that is complementary symmetry push pull amplifier, that is class B type we have seen. So this is the basic idea about the output stage and how it will be working, and at the last it will be providing the output. So this is the basic block diagram. So in this block diagram, you can see that different stages providing the different outputs, and this all stages are explained over here. Input stage provides most of the voltage gain of operational amplifier and decides input resistance. So mark these things, and at least that keep it in mind whenever we are going to discuss about the op amp. So intermediate stage is another differential amplifier which is driven by the output of input stage. So that is one thing. Due to direct coupling between the first two stages, the input of level shifting is an amplified signal with some non-zero DC level that we are providing. And what is being done at the after stage, that is level shifting, that it will be amplifying the difference or whatever the input is there, is being amplified at this stage, and DC level to 0 volts with respect to the ground. That can be seen that if you apply any kind of AC signal, or we can say alternating quantity is applied, then what happens that it will be providing the output as an amplified tones. So that is the thing. And after that, output stage is here, that increase the current supplying capability of operational amplifier and also provides low input resistance. So these all are the things. So you can be seen that the resistance is somewhat affecting the operational amplifier operation. Then what do we exactly mean by this? That operational amplifier input side resistance, or we can say the impedance, must be high, and output side the resistance must be low. So that we will understand whenever we come to the discussion of characteristics, or we can say parameters. So in these three different ways, the op amp input modes can be used. If you can apply only single-ended mode, then it is also possible. Only one terminal is there with the voltage supply, and the second one is the grounded. So that is the thing, and you can see the vice versa thing over here. We are providing some positive input, and we are getting the output terminal as an 180-degree phase shifted AC signal. So that is the thing, and here you can see the same phase sequence can be seen at the output terminal for the non-inverting terminal. So that's the things. After that, differential mode that we have used that we have studied in the differential amplifier, that how a differential amplifier will work. So here you can see both the input terminals are provided with some kind of voltages, and what it will be doing, that both are of its opposite polarity signal are applied to the two inputs of op-amp, and difference between the input signal is amplified, that is appearing at the output terminal. So that is the thing which is being take place in this differential mode. After that, you can see that common mode. Now what do we exactly mean? Both the signals are provided with the common input, and that is called as the common mode signal, common mode amplification mode. And what happens that zero voltage should be produced by the op amp at the output terminals if we apply the same input at this terminals. Why? Because the differential amplifier will work like that. If you provide the both the difference, then ideally it should be zero only, right? No difference can be found in this particular mode of operation. So that's why the output must be zero, right? So that's the thing. In the previous section, you have seen that both the signals are different, and the difference will be amplified at the output terminals. But right now, for the common mode, it is like that we have common both the terminals and provided a single input. So basically, we can able to understand that its difference will be zero only, right? So that is the concept of this operational amplifier. After that, we are going to learn about the characteristics, that what kind of characteristics is being shown by the operational amplifier, or we can say the parameters also. So this IC have different parameters, but more oftenly it is categorized into the two characteristics, that is AC and the DC. So first we will go for the AC characteristics, or we can say the in general characteristics which are being used by this operational amplifier, that is open loop voltage gain. Whenever we keep the operational amplifier in the open loop, that means no feedback is there. That we will able to understand in the next topics, which are inverting terminals and non-inverting terminals. So or you can able to learn these things also in the control system theory, that if we take no feedback, then it is a kind of thing that we are not bothered to what is being produced at the output terminals, and we are just keep on working on the same circuit, and it will be producing the same output at all the times. So that is the thing for the open loop voltage gain. So after that, you can see that input resistance, it is more oftenly whenever we talk about the ideal operational amplifier, then it will be just infinite times the input resistance, and the output resistance must be zero for the ideal conditions. But ideally, morely, we know that it is not possible that input resistance is not able to set at infinite resistance, but output resistance is also not at zero terms, but there will be some kind of input as well as the output resistance. So that's all for this input and output resistance. After that, the bandwidth, the signal which is being produced at the output terminals will have some bandwidth, and how much bandwidth is being produced by the operational amplifier at the output terminals, that is we more concerned about that thing. After that, the common mode rejection ratio, it is nothing but the differential gain and the common mode gain. It is the ratio of the differential gain and the common mode gain. Now whenever we use the operational amplifier into the differential mode, then it will be providing you some kind of amplification at the output terminals, and that is nothing but the voltage gain which is being produced at the output terminals. Now how we can get this? Then it can be achieved by output minus the input, and hence you will achieve the voltage gain at the operational amplifier. And same way, if we provide the both input terminals as an common signal, then it will be providing you some kind of output, or we can say the common mode gain. Whatever the gain is output at the output terminals is considered as the common mode gain, and the ratio of both this differential gain and common mode gain is called as the common mode rejection ratio. So that's it for the common mode rejection ratio. After that, we can come to the slew rate. And what do we exactly mean by slew rate? The slew rate is nothing but the maximum rate of change of output voltage per unit time. Means if we can see a particular spike at the input, uh, at the same time, at the same point of time, the output must be showing you some kind of change at its output terminals. Then and then the op amp is working as on good slew rate, we can say that. And this slew rate is basically performance parameter of this operational amplifier. After that, power supply rejection ratio, that is nothing but the change in the operational amplifier's input offset voltage is being caused by variation in the supply voltage. If you have a variable supply voltage, or we can say you have set that perfect supply voltages at the input terminals, but due to some kind of variation into the supply, the output terminals will be showing the different types of input voltages, and that can be seen that can be the effect can be seen at the output terminals. So that is the power supply rejection ratio. So these all are the main parameters. After that, input offset voltage, that is ideally for a zero input voltage, output should be zero, but it's not like that for all the operational amplifiers, that it will show you always zero voltages. So it's there is some kind of input offset voltage is being seen. So that's all. After that, you can be seeing that input bias current is there. Input bias current means the average of the currents flowing into the two input terminals of the op amp. That is nothing but if we take the input terminal 1 as an IB1, that is current IB1, and second terminal as current IB2, then both summation and divided by 2 is the input bias current of this particular operational amplifier. And the last, that is input offset current, it is the algebraic difference between the currents flowing into the inverting and non-inverting terminal of operational amplifier. So these all are the things. So let's have a comparison between these two op amps, that is ideal, and the second one is the practical op amp. So in this both the op amps, we can get a particular idea that how ideal and practical op amp is working, and what kind of practical values is achieved at the practical operational amplifier, and what kind of values is being achieved at the ideal operational amplifier. So you can see these things into the table, that input offset current is about 6 nanoamperes and the ideal value should be 0. But if you can see the bias current as 15 nanoampere and the ideal value should be 0. So that's how it is. And you can see that practical values of slew rate is 0.5 volt per microsecond. and here you can see that the expected slew rate is infinite. So it's like that, the things are at the ideal conditions and things are at the practical values are compared in such a way that how it is near to the particular ideal values. So that's how it is, and it is always considered like this. So after that we can see that for AC application we need to consider this kind of these parameters, and for the DC applications we need to concern about this parameters, that is input and output resistance, output swing, output voltage swing, and slew rate, input offset voltage and current, equivalent noise voltage and current, and gain bandwidth product. And for the DC application you can see input and output resistance, output voltage swing, offset voltage and current, voltage gain, large signal. So these all are the things which are need to take care at the AC applications as well as the DC applications. So that's all for the lecture. If you like my lecture and if you can understand these things, then do like and share the video, and also subscribe to my channel. Thank you.